Okay, so let me start. Welcome to the third panel that we organized. This is part of our corporate liaison program on Santa Clara Valley section. It is hosted by IEEE Industry Hub. That's a nice collaboration between these two organizations. And we also have other sponsors. IEEE USA has been generously marketing this, as well as IEEE Computer Society, IEEE Future Directions, and IEEE Industry Engagement. It's my great honor and pleasure to assemble here an outstanding set of speakers. From my left to right, would you like to introduce yourself, please?
Sure, yeah. First of all, hi, everyone. It's a pleasure to be here today. Thank you very much for inviting me. My name is Alua Suleimanova. I'm a sustainability manager at Marvell Technology. And for those of you who might not know what Marvell is, it's a semiconductor company. We make chips for big data infrastructure customers like data centers, 5G, carrier, and automotive. And I'm really looking forward to today's panel.
Okay, Mr. Patel.
Chandrakant Patel, I'm at HP, not the HP he's at. I'm at the HP that does 3D printing, client devices, and 2D printing and industrial graphics. And I've been in Silicon Valley for now 40 years. Started with Memorex large distribution, and now at HP. I was just saying, it's great that you're organizing this. This is the way we were, and that way we must be if we are going to bring silicon back to Silicon Valley.
Thank you, Mr. Patel. Celeste?
I'm Celeste Crystal. Thank you. Celeste Crystal, Director of Sustainability for DSA Memory. I'm located here in San Jose for the Samsung office, responsible for sustainability initiatives. And I'm so pleased to be here today and to speak with all of you.
Cullen?
Cullen Bash. First of all, thanks to IEEE for organizing this and putting this on. I think this is going to be a very interesting event on a topic that's of increasing importance to all of us. I'm with Hewlett-Packard Enterprise, so not the HP Inc. that he's from, but I started at HP at 28, something like that, years ago now, but who's counting? And I lead, I work at Hewlett-Packard Labs in particular, which is the research arm of Hewlett-Packard Enterprise. We are looking at creating opportunities for the company that we ultimately would like to transfer to our business units for commercialization. And I lead one of the labs within Hewlett-Packard Labs focused on system architecture.
And my name is Dan Milojicic. I am the chair of the Corporate Liaison Program. And again, thanks everyone for coming, both in person and online. So we're going to go with questions starting from this way, and then the next question we go backwards. And then at the end, I will ask you to provide 1 minute or 1 to 2 minute summary of your experiences. And then we'll open up for questions, both in the audience and online. We'll switch back and forth. So the first question is very generic. Awala, would you please introduce yourself, how you get acquainted with sustainability, what your company does, maybe up to 2 minutes.
Yeah, absolutely. I'm happy to. So probably should start by saying that I actually have more traditional background in sustainability and environmental management, and I pivoted to technology a bit later in my career. So I did an undergraduate degree in environmental science, and later in grad school decided to focus on water science and engineering. Initially worked in applied research, primarily within the water management space back in Germany, where I used to live before moving to the US. And then decided to do a pivot through consulting. First, I was a consultant with the United Nations, Convention on Climate Change, and then 5 years ago, moved to the Bay Area. And first worked as a corporate sustainability consultant with different Fortune 500 companies, primarily operating across data center, equipment manufacturing, and consumer electronics space, helping them with climate and corporate water stewardship strategies. And as I mentioned before, 2 years ago, decided to go in-house, kind of become a bit closer to implementation, and join Marvell Technology. So is this working? Yeah. Okay. In my role at Marvell, I focus specifically on our climate strategy, goal setting, stakeholder engagement, and external reporting and disclosures.
Thank you, Ola. Chandra?
So what I'm going to do is I'm going to leave the first part of what I did to Cullen, because we were all together. But I'll just say that the journey in sustainability started because we consider sustainability a business driver. It is not about paying more. It is about reducing the total cost of ownership And we recognized that in the 90s when we assumed that data centers of tomorrow will be built, which will be megawatts of power, and energy will drive the total cost of ownership. And that's how the journey began. And I'll let Cullen talk about that. I will pick up from where I left HP. So we were all together. And upon leaving HP Enterprise and coming to HP, I was intrigued by 3D printing, the art to part industrialization of 3D printing. So you might say that today, the way I drive sustainability is with the mantra net positive impact. The joules you save on the numerator and the lifetime joules on the denominator. So I look for ROI based on joules over joules, a dimensionless metric. And in that context, in 3D printing, if I were to devise an impeller in a pump or a compressor, the lifetime joules in 3D printing would be in the part, but the energy that is saved in the vehicle, if it's an electric vehicle, over the lifetime would go on the numerator. And I expect orders of magnitude savings. So in my opinion, sustainability, as we have always held, is not only a business driver, it's an opportunity to deconstruct conventional business model, replace them with what we do to reduce consumption in an entire sector. So I'm focused on reducing consumption in an entire sector, whether it's automotive and so on and so forth. So that's my kind of engagement with sustainability.
Thank you, Chandrakant. Celeste?
Thank you for this question. I really like it a lot. I started off working on the business side of semiconductors 20 years ago. And maybe I have a more traditional path as an MBA, working on products and product launches and studying the market. I worked as an industry analyst previously, so market strategies, competitive strategies, and kind of looking at this forward. You know, I am not coming from a sustainability background, and yet it made a lot of intuitive sense for me to pivot into sustainability. So when someone tapped me on the shoulder and said, it's time to work on a sustainability project because all the customers in Silicon Valley are asking for more details around this, and we need someone with your business-focused skill set to go in that direction, it just seemed like a very slight pivot over from what I already do and have done for several decades. So that's a different approach to sustainability, but I think it's a really strong argument for why and how many of you, if you're coming from an engineering background, if you're coming from an MBA or product manager background, the future is heading in this direction. So I might have been the first, but I'm certainly not the last. And I want to just show this as an example for everyone to see that this is kind of the direction things are heading, and we're not moving back from this. It's just gaining more and more momentum in this direction for business. So with that, I'll hand it over to Cullen.
Very interesting, Celeste.
So I'm a mechanical engineer, and when I was in graduate school, I was interested in how to move energy from point A to point B and do it in the way that's most efficient as possible. So I was interested in heat transfer, fluid mechanics, thermodynamics. Out of school, went to work at a product development division within HP, and ran into Chandrakant at one point
In the stockroom.
In the stockroom, yeah, where we had the garage, we had everything at our fingertips that we might need to design and build something. And at that point, I decided, I wanted to go work at labs with that guy. And so 3 years later, we made that happen. And so we started to think about and investigate every conceivable way that we could think of to move heat from a chip and to a system out into the external environment. And after a while, that led us to thinking about, at the data center level, how do we do demand management at the data center level, energy demand management, by integrating the IT systems within the data center with the facilities. So really looking at it kind of holistically, because ultimately those two things are connected, right? And so we tried to connect them. Once we did that, we got interested in supply and demand management. So if you do demand management, how do you match demand and balance demand with the availability of energy on the supply side, and in particular renewable energy, right? So we built 12 years ago now, something like that, the first net zero energy data center that I think had ever been built. And in this case, we had a photovoltaic array attached to the data center, And we were doing demand management in order to maximize the use of that photovoltaic energy versus the energy from the grid. And to do that demand management, we had to turn systems off. And so then I started to get interested in the whole notion of energy proportionality in systems, joined a big project within HP at the time where we were focused on developing that next generation of system that had energy management and energy proportionality kind of at its core. Still interested in that today in the role I have at Hewlett-Packard Labs, but also started it, and I'm working now with, a broad team within the company in trying to meet HPE's goal that we announced a couple of years ago to be net zero carbon emissions by 2040 with a midpoint of 2030. So helping develop the strategy for how we're going to get there across the company and across our research program.
Thank you, Colin. These were really sustainable 2 minutes. Let's move, rather than going backwards, let's move N+1. So Chandra is the next. And the question for you is, what are the key sustainability aspects that the industry needs to focus on today?
So first, the industry needs to stop virtue signaling. I'm kind of tired of, I'm the most sustainable and just company, blah, blah, blah. And the anecdotal approach to sustainability, giving lectures to people, that needs to stop. I think industry needs to ground. Sustainability must be grounded in fundamentals. And I am a second law aficionado. Available energy is the currency. So for me, whatever choice we make in sustainability, no matter what choice we make, we will always lose. We have to take a balanced perspective. So in that context, the decision we make in sustainability should be grounded in the fundamentals of engineering. And the framework we have created in sustainability is very clear. On the supply side, when we are considering energy, look at the portfolio of available energy. On the supply side, think of cradle-to-cradle available energy used across the life cycle, including negative externalities. The burden we create today, which we are not accounting for, climate change is the biggest negative externality. Look for available energy in waste streams. So that's on the supply side. And on the demand side, like Colin was saying in the data center, allocate the available energy based on the need. So having a holistic fundamentals-based framework based on second law of thermodynamics should guide our sustainability decision, as opposed to saying, I did this and I'm sustainable. So I actually challenge engineering students, particularly mechanical engineering students, to take that, move ahead with that perspective, grounded in the classes they take.
Thank you, Chandra. Celeste, can you challenge this position?
I don't think I want to challenge this position. I mean, you are definitely preaching to the choir.
Right.
And when it comes to priorities of what's happening in sustainability, all of us here in the audience recognize that being a technologist and creating technologies to make technology more sustainable can be our superpower. And we know how to do this. And at Samsung, I have an easy job. I just outline what our technologists have created to make technology more sustainable. On the manufacturing side, they've worked on products and new innovations in our R&D center to help decarbonize in that area. When it comes to products that are being launched, also with greater energy efficiency, but still having the same kind of performance that's required going forward in the future, and investigating and looking at this more closely going forward in the roadmap in the future. And then even beyond that, when it comes to rethinking waste or how we use waste and circularity, there's a huge opportunity in innovation there. And there's some really interesting new ideas that are happening at that R&D level on how do we reuse and how do we make the most of what we already have, and maybe rethinking how we think about innovation going forward in the future. So I think this, in addition to looking at energy and the energy mix and as a data input to manufacturing as being a major critical area of further investigation, there are many things going on with technologists and chemists and engineers, and most importantly, people talking to each other who have never really spoken to each other before. Sustainability managers talking to product engineers, manufacturing experts talking to chemists and experts who are, organic in the organic chemistry, rethinking the materials and the material science of what is being used. and those outputs. So, 50, 60 years ago, the semiconductor industry was not built with sustainability or ESG terms in mind. That was just not what it was. But now we're rapidly changing to adapt. And that's, just sort of a natural progression of how business works. And, I'd like to see us leading the way here in Silicon Valley because we know how to do that.
Yeah, very nice. Colin?
I think to build on that, first of all, it takes multidisciplinary approach, which is what Celeste is talking about. But what I think, and to build on what Celeste was saying, sustainability has to be elevated to become a first-class design citizen, along with performance, functionality, with cost, with whatever we tend to think of as the drivers of design at the beginning of a design process. Sustainability has to elevate to that level. And that's through the whole industry. And that means different things to different parts of the industry and different companies, but it needs to rise up. And it needs to do so over the life cycle of the entire product or solution that we're thinking about, from manufacturing to use phase to end of life. And there are opportunities within all of those phases. So on the manufacturing side, a lot of effort right now is on thinking about, all right, how do we measure or estimate embedded carbon in different elements of the manufacturing process? There's opportunity as we think about how these different streams on the supply chain side come together to think about how we standardize embedded carbon reporting, so that when we do report from these different streams, we can pull those together and aggregate them in a way that is sensible and reproducible and useful for anything we might want to use it for downstream. On the use case side, since my team and myself tend to work in systems and think about systems, there's any number of things that we can be focused on in systems. But one of the things we're interested in, we've been looking at for some time, is specialization, right? Think about heterogeneity in systems, the ability to take specialized hardware elements like accelerators, for example, and build them in a way that is more energy efficient and best suited for specific types of workloads, rather than sending workloads to general purpose systems, send them to special purpose hardware. There's a lot of evidence that for specific types of applications, we can save a tremendous amount of energy doing that. I came across an article a couple of weeks ago, actually, that was written by Carnegie Mellon University, some researchers there. And what they're starting to look at is they're comparing energy consumption of task-specific AI inference algorithms with general-purpose AI inference algorithms. And what they're finding is that the energy consumption of task-specific is much, much lower than general purpose. So mounting evidence that if we target specialization, there's benefits to be had from the energy perspective. And then I'll just echo what Celeste said for end of life, because we talk about recyclability a lot, and that's important, but we need to be talking more and thinking more on the design side about reusability. How do we extend the life of systems? How do we reuse components or devices so that when they maybe are at end of life for the first use, there's another use case that somebody else could benefit from that doesn't necessarily require the latest generation of devices, of components that could benefit from that second generation. So how do we extend that life? All of that under the umbrella of elevating sustainability, make it a first-class design citizen.
Yes. Thank you, Colin. Let's wait with the questions until everybody has the chance. Aula, what have we not addressed so far?
Yeah, no, thank you so much for sharing this insights. It's definitely resonate, and it's great to see that it's becoming already mainstream in our industry. Maybe what I wanted to add to this discussion is kind of bring a little bit of a climate perspective, again, because of my role with Marvell. I think the key trend that we are seeing in the semiconductor and the technology space in general, and that actually mirrors the approach we take at Marvell, is to take more ownership and to address climate impacts outside of our four walls. Right? I think a lot of companies have been already looking at their direct operational carbon footprint by procuring energy, trying to make their buildings more efficient. But nowadays, the discussion around so-called Scope 3, right? I'm sure many of you have heard this term, is really emerging to the top of the corporate agendas. And it really means to look at upstream, so emissions associated with suppliers, and downstream, looking at the use phase of products. And for Marvell, maybe just to give you kind of a more tangible example, we as a fabless company, we primarily focus on the design of semiconductor products. But we outsource the full manufacturing, or the full fabrication process to third-party suppliers. So for us, obviously, the upstream climate impacts are really important. everything that concerned with supplier engagement, how to influence their behavior, right? And to really encourage them to look at renewable energy options within their facilities, to look at F-gas abatement technologies, definitely relevant for big fabs. But if you look at, for example, Marvell's total company-wide carbon footprint, you'll see that the majority of our carbon emissions actually lie downstream. And that was very surprising for me to see when I joined the company. And that definitely made sense because we're a hardware company, right? We make chips that end up within big data infrastructure systems like data centers, which run pretty much 24/7. So these products continue generating emissions pretty much throughout the full lifetime. And something I was also surprised to learn when I joined the company is that many semiconductor companies consider chips as intermediate products, right? They're never being deployed just by themselves. They always end up as part of a bigger systems. And that's why the carbon accounting around the use phase of those products have been slightly overlooked, right? Because there are so many uncertainties. And how do you actually estimate carbon footprint related to those small chips, right? Being part of a bigger systems. And the approach we took at Marvell is a couple of years ago, our sustainability team actually approached our central engineering unit. And to Celeste, to your point about stakeholder engagement, right, and taking systems approach, it was definitely important for our sustainability team, first of all, to learn how are we measuring power performance of products at the moment. So we started really with creating a baseline. We looked at factors like power consumption at a product level in the use phase, the use profile, right, whether it's a product that's being used in data center versus a car, and definitely the location, because as you know, the electrical grid varies a lot, right, across different geographies. And so we definitely want to make sure that the location of the end use is taken into account. And so by looking at these factors holistically, we're able to estimate that baseline. So understand what our current power consumption looks like. We later translated that into carbon emissions, but we also coupled this exercise with building forward-looking projections. So we looked at our future sales and took into consideration products that are not yet on the market, but will come online in the coming years. And so that way we were able to build a forward-looking carbon reduction roadmap. And I think the reason why this topic around product power, right, and building sustainability into product design became such a priority for Marvell, and I see this in our industry in general, is because it's not just a very efficient way to address carbon footprint, but also because it's a really strong business case. And we see more and more our customers really demanding for products that have high performance for the same or even lower power than older generations. And so that's why product power has been such an important factor for us. And maybe just to kind of conclude that, last year, several semiconductor companies, including Marvell, came together to form the so-called Semiconductor Climate Consortium. It's great to see both HP and Samsung being part of that. And so how do we collectively, suppliers, customers, right, companies at different segments of the value chain come together and tackle all these very complex and highly scientific topics concerned with supplier emissions, sustainable product production, and really address this together, because definitely it's a huge issue to won't be able to address in silos or individually.
Great conclusion.
I want to challenge my panelists at some point.
Okay, so we'll have at the end the opportunity to make closing statement. Would you mind waiting until we only have a couple of questions plus statement? The next question with Celeste starting. How can academia and governments help?
Oh, absolutely. This is the right timing for both academia and governments to kind of share the burden of responsibility of all of this together with industry. And again, this is an area where maybe these three entities have not really collaborated that closely in the past. But now there's this new call to action, and it's due to an existential threat that we're all facing generally throughout humanity. So I think this is pulling institutions closer together that maybe haven't worked traditionally that well together, or even felt compelled to work so closely together. So we're seeing new models emerge with the purpose driving results faster, coming to decisions faster, and sharing common goals. And being able to describe these common goals is already just like step one. Then to utilize technology to get us to those next phases, and also rethinking even economic models, capital and financial models. This is kind of calling all the resources into action for everyone to kind of come together to bring what they can to the table to come to solutions more quickly. So this is one of the first times in business I've seen this kind of activity happen so quickly, springing into action with additional new results and new frameworks that are being introduced for the very first time. We've often talked about like co-opetition in the past. These new models bring into a whole different kind of scenario. I don't even know what the name of it is right now, quite yet. But there will be a name for it in the future. We're just inventing it, and we're taking those steps forward, not necessarily knowing what the end result ultimately will be. But there's a lot of improvisation happening right now because of the speed that needs to happen for all parties involved.
Excellent observations. Colin?
When I was thinking about this panel and some of these questions, and particularly the academia one, I was thinking back, is there a time in my career, specifically in the research side of things, where we haven't been collaborating closely in some form or another with a university, with a professor, with a student? And I couldn't think of one. It might be there, but it was probably a very small period of time. And so academia plays a huge role in what we're trying to do. They're a source of novel ideas. They're a source of innovation. I'll give you an example. And I think this one was actually born from Chandrakant. I'll give you credit for this, which was an idea that we had of could we use the second law of thermodynamics? You all know what the second law of thermodynamics is, right? First law, energy can't be created or destroyed. Second law is that the quality of energy can, in fact, be destroyed. And so the idea was, can we link the destruction of exergy, that's called exergy, the quality of energy, with as a proxy for estimating sustainability of a process? And so we reached out to a professor we knew at Berkeley, Professor Van Carey, and he had a student, Amit Shah, and we posited this idea to them. And sure enough, turns out you can do that. You can link the second law with sustainability. And Amit got his PhD on just that topic alone. But we wouldn't have been able to make that progress, I would say, without those two, right? We couldn't have done that on our own. And so this collaboration between industry and academia is incredibly important. Government is, among many things we could talk about, one of the things they do that's powerful is they provide funding to de-risk technology, right? And that funding goes to academia, it goes to industry. But what they're trying to do in these cases is accelerate either fast fail, right, or accelerate the path to commercialization. And in sustainability, we don't have a whole heck of a lot of time when we think about climate change and some of the things going on. COP28 they just convened, right, a couple of days ago. And one of the things they're looking at is, well, how close are we to that 1.5 degrees C rise that was indicated at the Paris Agreement in 2015 that we really want to try to avoid, right? We're getting closer to it. So we don't have a lot of time. How does government help us accelerate the time to solution, either through academia or through industry? There are other things too that both of those institutions can help with, those entities. But I do think that moving forward, there has been in the past, and there has to be going forward, this trinity of industry, of academia, and of government coming together to solve, big problems, and this is a big problem.
I like the term trinity. Aula?
Yeah.
Thank you, Colin.
Sure, yeah. I'm sure many of you have been also following COP28, right? The United Nations Climate Conference. It just wrapped up a couple of days ago, and it was fascinating to see some of the stats that have been shared. So effectively, in order for us to collectively continue being in alignment with our Paris Agreement goals and to limit the global emissions below 1.5 degrees C, we need to triple the amount of renewable energy that we have now and reduce global emissions by 43% by 2030. Right, so it's a massive task, and I think the key role that both government and academia can play is really around renewable energy. We need more research to get a deeper understanding about different energy systems, how they interact with each other, and to also make some of the more novel studies open source and available for companies, because it's really exciting, actually, for me as an environmental scientist to see that approach that companies are taking nowadays to renewable energy are becoming much more sophisticated. Right? There are a lot of people with PhD and a former scientific background working in the private space. And so definitely having open source publications to access those data and more up-to-date findings is crucial. And on the governmental side, I think the key role national governments can play is to really help stimulate those renewable energy development projects that require a big scale. And again, to give you an example from a semiconductor space, probably all of you know that the Asia-Pacific region is an important hub for semiconductor manufacturing companies, but historically has been really lacking access to renewable energy compared to Europe or the US, more mature markets. And I think there's a lot of opportunities also for collaboration between corporates and the national governments in that region to enable access to renewables and essentially physically adding more renewables to electrical grids and facilitate that low carbon transition.
Thank you. Challenge away, John.
No, I'll come back to that challenge section. I just will focus on this. And I'll just add to what everybody has said in terms of research. So I'm going to focus on curriculum. The systemic underinvestment in physical sciences has left us ill-prepared for the cyber-physical age and sustainability. We are grossly over-provisioned in cyber sciences, under-provisioned in physical sciences. About 10 years ago, I was in Gardner Brown's office, and the concern of the team was, the people who run our power plants are retiring. My son is doing cardiothoracic surgery. He'll be 20 years out of high school before he becomes one. Practicing cardiothoracic surgeons, there are only 4,000 cardiothoracic surgeons in a country of 333 million. Well, you could just go to TikTok and make 200K a year. Why do you want to be a resident at 70K? But the thing is, we cannot fight the market. We value entertainment. For now, that's fine. But the problem is, while we cannot change the market, the time constant for training physical scientists is very long. So the biggest change we must make, in addition to everything that has been said, is focus on a cyber-physical curriculum, return to physical fundamentals. The silos that are teaching fundamentals, continue to teach that. Even in the age of AI, when you are in power, water, waste, domain will need AI. AI, think of it, generative domain AI, not generative AI, when it comes to power, pathology, so on and so forth. So I think the most critical thing we may do is return to the way we were in fundamentals in physical sciences and create T-shaped contributors who are depth in physical sciences, breadth in cyber sciences. So MS and PhD in materials, mechanical, economics, and all disciplines, social, economic, ecological considerations are important as well. So breadth in social, economic, ecological, and cyber sciences. We just penned an article I'm a member of the National Academy. We just penned an article in the National Academy to advise the government precisely on this. So the measure of success, if we start doing now, this curriculum change, in 2030, when I ask a room full of people, early career in sustainability, where does your water come from? I will get an answer. That room full of people in Palo Alto, I'll get the answer that starts at the Hetch Hetchy Reservoir, the top water level of this reservoir, all the way down here, and they will tell the history of how O'Shaughnessy, 100 years ago, fought it out with John Muir to dam a valley as beautiful as Yosemite, displace the people there to build a hydro plant which supplies water to us. I want that level of fundamental knowledge. We are living off of infrastructure that our ancestors built. In Fremont, I live close to Chabot Lake. 800 Chinese immigrants use shovel to build that lake. I go and bow to them. I tell my children to bow to them because we don't have any other infrastructure. We must preserve that infrastructure. So I think on the supply side, we have a huge challenge. We need to quickly move fast in the direction of the curriculum. Sure, in the physical sciences, include the latest in AI and data sciences, but the time has come to return to physical sciences and return to the right provisioning. And that is absolutely critical. I'm really concerned, particularly given we are an aging population. So power, water, waste, transport, all the people who know that are retiring. We better get their domain knowledge codified and create a chat GPT so our youngsters can ask, where does the water come from? How do I fix that compressor? And so on.
Thank you, Chandra. Very memorable examples. And we have the last question before I'll ask you for the summary, and then we'll switch to the Q&A. Do we need help from professional organizations such as IEEE, there are others, mechanical engineering, ACM, and others? So starting with Colin.
Yes. Should I elaborate? Yeah. So professional organizations are hugely important, right? So what they do is bring together people from different backgrounds. You know, IEEE is pretty broad. It brings together a certain type of people that have certain interests and areas of expertise. ASME, mechanical engineering, there's some overlap, but largely a different group. And you know, societies, I think, sustainability is so broad, and it's going to require expertise in so many different areas that there's an opportunity for societies to work together. There's a conference that is held every 2 years, and it's called INTERPAC. It's the Intersocietal Electronics Packaging Conference, something like that. And it's sponsored by IEEE and ASME, by the Mechanical Engineering Society, by the Electrical Engineering Society. It's focused on electronics packaging, where there's a need for mechanical engineers and electrical engineers to come together into a forum where they can discuss opportunities, discuss solutions that require that multidisciplinary approach. I'm sure something like that is happening in sustainability. I know that there are areas where multiple societies are getting together, but this is an opportunity. If we think about the future directions of IEEE, of ASME, of other societies, sustainability is in there, right? So at what point can societies help bring these groups together? And then the other thing, I want to give IEEE some kudos. And they every year they come out with a document that describes megatrends. And within, sustainability was identified as a megatrend just this past year. And then they deep dive into those megatrends to discuss the trends that are building those megatrends, right? And so our esteemed panel moderator, I know, is a big contributor and leader in this area. And so, that's a way that societies and professional organizations can help. This is going to evolve over time, right? And so we have to stay on top of it. And these organizations can help with that. The second thing that IEEE does is technology predictions. Same kind of thing. What's coming around the corner that we should be looking at? And I think we could morph this a little bit, focus it a little bit into sustainable technology predictions. What should we be looking at that's coming around the corner? But I think in ways like that and others, professional organizations can help.
Thank you, Colin. Aula?
Sure. Yeah. No, thank you so much for sharing these insights. I think I'll probably limit kind of my overview to 3 examples where I also see a huge relevance to the semiconductor space. I think sustainability is evolving so rapidly that it's for any company, even if they have a very big sustainability team, so hard to stay abreast with all the new developments, be it new emerging climate regulations, new guidance documents, new tools, right, new methodologies. And so I think that's where the professional organizations could really help a lot by giving access to white papers, more up-to-date data and information that companies can use. The second, I think, is definitely networking opportunities. I already mentioned the Semiconductor Climate Consortium. We're also a member of the Responsible Business Alliance, the Climate Energy Buyers Association, and they have all great models of offering essentially platforms for companies to come together, right, in a non-competitive way and really be transparent about how they each tackle sustainability and climate issues internally to find synergies, talk about common challenges, and really learn from each other. So I think that's great. And the third one is definitely around conferences and events, even like today's one. I think it's definitely important for companies to kind of take a bit of a big picture look, right? To step away from a desk for a bit and really connect with peers, maybe even people looking at sustainability from a non-environmental lens, but from an engineering or legal or finance perspectives, and kind of really is starting to come up with more creative ways, because more and more, when I go to these conferences, I hear from people that in order to solve these challenges, we need to come up with a novel approach, because they're dealing with newer issues, problems that haven't been in place before. So by using kind of older solutions wouldn't work. And so I think these three examples probably definitely where these organizations can bring a lot of value.
Thank you all. Chandrakant?
So Colin, let's take the example of trend. So in light of socioeconomic, ecological consideration, what is the technology trend? And you publish this. We have to do that. But what I find missing is we publish the trends, we say digital twin, blah, blah, blah. How do you do it? Sustainability is not a subject. It's not it's become a tantamount to do this and don't do this. Instead, do the mega trends, determine the technologies, and then the societies, IEEE, ASME, and others, must figure out a way to teach people how to execute on those technology. So think of, now that silicon is coming back to Silicon Valley, we should have 2-year certification programs. What are we doing with community colleges? How are we going to create the legions of technicians that are necessary? So if we train them and they know how to properly do the work, we will get sustainable outcomes. We can't teach them sustainability. We need to teach them electrical engineering, mechanical materials. So I think the focus of the societies should be on 2-year certification to create the large numbers of people, and then also at the curriculum level, so that people learn how to execute on the technologies that are delineated as part of the mega trends. I think the execution part is where we are falling behind. And furthermore, we just don't have enough people, right? So we've got to act fast. And so what I find, and which really frustrates me, is all these mega trends and so on become a very good slide deck. Digital twin, blah, blah, blah. I want to shoot myself. How do you build it? It's frustrating to me that when we don't go into action and show the modus operandi, how do we go and build that? That's what they should focus.
Thank you, Chandra. And Celeste, to close.
Okay, to close it out.
Save digital twins.
Well, I do want to share that I'm from the Bay Area. So as a Bay Area native, I always look to IEEE for the information and knowledge that I could trust when it comes to technology and innovation. Sort of like what you mentioned. This is the actual source. You know, the tagline of technology for the benefit of humanity. I think that still stands true today. When people need a reliable source of truth when it comes to technology, to read some, non-marketing related white papers, this is the source of that information. So I think it's getting back to Silicon Valley's roots, and also realizing that sustainability is just a pivot. It's also technology for the benefit of humanity as well. So it's not a huge leap. We're just getting back to our roots here in the Bay Area, locally, but also being able to expand and scale with the global footprint of IEEE. This is something that's very exciting, and it dovetails exactly into the conversation we had about globalization and businesses and connection amongst many different types of people across many different countries and borders and disciplines. So I think now is absolutely the right time to get more involved with IEEE. I'm so thankful for the opportunity to be able to be here today for the very first time at an IEEE meeting. So for me, it was something very distant, very far away. Maybe some papers I read in theory, right? But it's actually something very real, very tangible that we can experience today. And it's definitely the right moment in time for this collaboration to continue.
Thank you, Celeste. So we're going to do something very interesting now. I know Chandra is all ready to challenge us, but we're going to limit in sustainable 1 minute closing statement. We're going to go backwards. Colin, you have exactly 60 seconds now. Starting now.
All right. Within sustainability, sometimes we can be overwhelmed because there's so much to do. I get asked quite frequently, where do we get started? And look, the fact that we're all here, we're all discussing this topic is super heartening to me. I like to break the problem down. We talk about this internally within HPE, that there are kind of 4 things to focus on. Reduce energy demand, reduce reliance on fossil fuels, embrace circularity and extend the end of life of the
30
things we're doing
seconds.
today. And you made me forget the fourth thing, but decarbonization. How do we deploy technology for decarbonization? So I'm going to wrap it up by saying we need to elevate sustainability again, make it a first-class design citizen.
Excellent.
I know
50
how to
seconds.
distract him. I know.
Celeste, 60 seconds.
When I think about sustainability, I think of sustainability being a vector of innovation. And if we follow that North Star, we're going to lead to excellent results, fast results, innovative results, things that haven't been created yet in the world. And I think that's the essence of innovation. So I think that's kind of my approach when I think about sustainability and its relevance to all of us here in the audience and to my everyday work. It's my guiding star, and certainly it guides the conversations I have with people from throughout different companies, different partner ecosystems, different folks who collaborate with us across academia, across government, industry, students, young people, fresh new ideas. I mean, that's the essence of innovation. That's why we're all here today. So that's my guiding star, if you will.
Thank you. Chandran?
Net positive impact. When my garage door failed, I realized that I would have to replace the whole thing. So I looked at the track. I estimated 0.2 gigajoules had gone into making that steel track. So I put it in the backyard, created a clothesline, used it for 20 years. I saved 80 gigajoules. That goes on the numerator. On the denominator goes 0.2 gigajoules. And that's my net positive impact. Then I looked at the humble clothespin. Then I bowed to the clothespin. Because the clothespin, I've been using the same 50 for 20 years. Infinite net positive impact of the clothes that it. So when, you know how I came up with NPI? When my kids did frivolous activity on the internet, I asked them to calculate the joules of available energy destroyed in moving those pictures into the cloud. And I asked them, did you get a net positive impact?
60 seconds. Perfect. Chandra. Howell?
Great. I think what I'm personally very excited about sustainability space is that nowadays you actually don't have to be an environmental scientist or to study sustainability. I know it's my background, but it doesn't need to be in order to do sustainability. And I think it's really interesting, kind of going back to the first question, that we all have such different career trajectories, right? But somehow ended up in the same space. And I think what I'm also really interested about sustainability and technology is that tech space, I think, is the one where the solutions could be coming not just by strategies around managing supplier operations or direct operations, but actually through products. And I think sustainable product design, right? And how do you leverage innovation for sustainability, for power optimization is really exciting. And so I've personally really enjoyed my journey so far.
Thank you very much, Aula. Let's thank the panelists.